Here we are at our example 3 from our 4.3, number 5 set of notes. We're asked to factor down this trinomial. And we always start by first identifying what is our A, B, and C. So A here is 8, B here is 38, and our C value is 42. Now before we really dive deeper into this, you can factor down the way that we've been doing it, okay? You can do that. The problem with that process is you're going to end up with a lot larger numbers when you try and find your AC value, okay? So like if you did 8 times 42, it'd be something crazy into the hundreds. Now, one thing, though, that you can use to really help yourself, and you got to star this, okay, is remember rule number 1. What is rule number 1? It is if you can pull out a GCF right away, do that because it will make your life way easier. Okay? You'll bypass a lot of different potential factors, and you're just going to be working with a lot smaller numbers in general. Okay? And so when we look at our 8, 38, and 42, we notice that they're all even, right? And so then the GCF of that would be, you can't unfortunately do 4, but you can do 2. So you can divide them all evenly by 2. And so if we pull out a GCF of 2 in that case, you've got 2 times 4n squared plus 19n plus 21. Okay? Now, while that didn't necessarily seem like quite a big step, actually you've eliminated a lot of potential different factors. Okay, so now our focus is actually breaking this guy down, the 4n squared plus 19n plus 21, because we have to factor this thing down completely. And now, as a result of that, our A value, our B, and our C have actually changed. We're now going to go ahead and use those values after you've pulled out that GCF. So now we're looking at 4, 19, and positive 21. So now you're going to go ahead and use your X method that we talked about before. So on the top part, you have A times C, which 4 times 21 gives us 84. We then look at our B value. In this case, B here is 19. So we're going to use 19. Now comes our list of those factors for 84, the A times the C. And so when we create our list, I always advise students create the full list just because you're going to get a lot more fluid when you're doing these then. So you have 1 and 84. You've got 2 and 42. I'll see here. We've got 3 and 28. We have 4 and 21. It's not divisible by 5. It is divisible by 6. So we have 6 and 14. And you multiply those two together. And it is divisible by 7, actually. 7 and 12. When you multiply those, you get 84 as well. So that is our list of those perfect squares. Okay. And again, you would try and ask yourself, which of these pairs combine to give us the B term positive 19 in the middle? Well, 1 and 84 don't do that. 2 and 42 don't do that. So we notice how we created the entire list until eventually we got to the pair that will give us 19. It's 7 and 12. So we have 7 and 12 as our main numbers that we're going to be using to break this down. So 19 is pretty much getting broken down into 7 and then n, and then 19. I'm sorry, 12. 12 rather. Trying to get 19. Yeah, 12. And n. Now, we notice how we have a positive 19 there for our B value. Well, in order to get that to be a positive 19, we would need a positive 7n and a positive 12n. Right? Now, we have a 4n squared, and our 21, they just drop down. Okay? And now we're going to go ahead and factor by grouping. Well, when we look at our first pair, these two values, we end up with, we can factor out an n. So we have n times 4n plus 7. And when we look at our second pair, we notice that it's factorable by a 3. We can pull a 3 out of each one. And then we would be left with 4n plus 7. And since they both share that common factor of 4n, you're pulling that out, giving you your 4n plus 7 factor. And then you would have your leftover stuff, so this n plus 3. Okay? And so often, if this is what you got, so often I get this kind of final answer, and it's actually wrong. And unfortunately, you're like crazy close to the correct answer, but I really don't want you to fall for this trap. Okay? And if you're wondering, like, well, if that's not the final answer, what is? Don't forget, right here, you pulled out a GCF from the start, right? You need that in your final answer, okay? So do not forget a GCF if you pulled it out from the beginning. It is very easy for students to accidentally forget that step just because you did it maybe so long ago that, you just kind of forget about them. But please do not forget that GCF that you pulled out from the beginning, okay? Make sure it's in your final answer. Again, though, that is example 3 from our 4.3 number 5 set of notes.